I'm going to show you now how to enter the encryption contest. So the rules for the encryption contest. To enter, you must hand in an encrypted file called yourname.txt. So if your name is Joe, you got to hand in a file called joe.txt. The file must encrypt the lyrics of a song, and that song must be written in English. You must have a program that can fully decrypt your own encrypted file to demonstrate that it's possible. So you can show you didn't just destroy the data, you actually encrypted it in a way that the information is preserved. And finally, as the contest starts, all encrypted files will be shared with all of the contestants. So you get to see everyone else's encrypted file. And finally, while the contest is on, you get 5 points every time you hack another contestant's encrypted file. However, you lose 1 point every time you are hacked. So you can end up in the negatives. If you don't break anyone and 6 people break you, you end up at a -6. Okay, so to get started, what you need is to have is a file called plaintext.txt. Well, you can call it whatever you want. Mine is called plaintext.txt. And that's got to have the lyrics for a song for this contest. The song must be written in English. You're then going to write a program that encrypts it. So your starting point when you go to encrypt it is you need to open up your file. So this opens the file. And then S1 equals f.read will read the file in, and S1 becomes a string containing the entire file. Now, you don't need to do this. I'm just, when I run this so you can see, I'm going to print it onto the screen. So I'm printing out that S1 and then closing the file. S2 is an empty string, and this string is going to contain the encrypted version of the file. So when I encrypt it, I am iterating through my string. So I'm iterating through the song, where the song is all a single string. And for each letter in it, I am adding to my new string the ORD of the character. Now, let me just show you what the ORD is. So let's say my character is the letter G. So let's say C is equal to the letter G, because the first word, well, the title of the song is Good Feeling. So if C is the letter G, ORD C is the number 71. The letter capital G is represented inside the computer as the number 71. That is the ASCII system and the Unicode system. The Unicode's like a superset of ASCII. So what this is doing here is it's creating a string of all of the numbers that represent all of the letters. So when I run this, it's taken all of the letters from here and represented them as each of these numbers here. So the 71 is the capital G. The 111 followed by the 111 is the 2 O's. The 100 is the D. And finally, this space is represented by the number 32. Because notice there's a space between each of these numbers that represent our characters. That space was created here. See, if I took the space out, let's say I was to not add a space in there and run this, it would concatenate all of the digits. But that's no good, because when you go to decrypt that, how do you know it's a 71 followed by a 111? Because this could be a 71 followed by an 11. Or it could be a 711 followed by a 111. So we need a space between each of them. That's why I've added a space here. Also notice I had to convert that to a string, because when I type ORD C, it comes out as an integer number. that integer must be converted to a string so that I can add the strings together to create that longer string, which I will then write into the ciphertext. So you can pause it if you want to copy the code. Let me just explain it quick line by line. So this opens up your file called plain text. This reads it in. So it's in RAM, and it reads it in as S1. So S1 is the name of our string that contains the entire song. I printed it to the screen just to verify this is working, and it's always good practice to close a file when you open it. We then create a second string called S2, and I'm iterating through my first string, grabbing it one character at a time. So C takes on the value of each character, the G followed by the O, followed by the O, and so on. ORD gives me the number associated with each of the characters via the Unicode table. You can look up Unicode. STR converts that into a string, and I'm adding the strings together with spaces so that a space shows up between each of the numbers. And finally, I'm printing it on the screen to verify that it's all working. And now here, I'm opening up a new file. I'm calling it ciphertext. And notice I have a W here. That allows me to write a file. So right now, where ciphertext, let me erase that. So let's say ciphertext does not exist. When I run that, it's going to create a file called ciphertext and write it there. You got to be careful here, though, because if you do that, if you create a file but one already exists, it will overwrite it. So you'll lose whatever was written there. So be careful about file names when you do that. So finally, we're writing our ciphertext, and then we're closing. So when I write this, when I run this, it's going to take that song, it's going to turn it into those numbers that represent each of the letters. And notice now it's created this file here called ciphertext. So this is my file, and it's been encrypted. Now, this is really weak encryption. We're going to want to do something with the numbers because it's going to be very easy to hack. My program that decrypts this now looks the exact opposite of the program that encrypts it. So let me show you them side by side. The program to encrypt it opens plain text, reads it in, and ORD converts each of the characters into a number. My program that decrypts it opens the ciphertext, reads it in, and then CHR converts each of those numbers into the character. So I'll show you in the shell. If I have a number, so let's say I have that 111. So let's say n is equal to 111. The character of 111 is the letter O. So this converts those numbers back into characters. And then I'm adding them together to create my decrypted string, and that's how I get the song back. So when I run this, what this has done is it's taken in my ciphertext, it's taken in those numbers, and it's turned them back into plain text here. Now, just one thing to watch for. So you've probably noticed there's a couple other things here. See that INT? What's happening is the numbers in the text file have been saved as a string of digits. So when I read those digits one at a time, I've got to convert them into integers before I can find the character associated with them. This character function converts integers into a character, not a number represented as a string into a character. Another thing to watch for, notice the split. The reason why I did that is as I iterate through my ciphertext, I want to grab these numbers, not the individual characters. See, my first character is a 7, but the number is a 71, and my numbers are separated by spaces. So that dot split turns my string into a list. This list contains all of the numbers separated by spaces. Let me just print it right out here so you can see that. So I'm going to print, that's an L1. And then, I don't know, temp equals input. So I'll just get it to freeze right after it does that. I'm going to print that list. So as you can see here, I've read that in, but I've converted it into a list. Now, see the quotes around here? That's telling me that each of these list items are actually a string. They've got to be converted into integers before I can then find the character associated with them. I find those characters, I add them up to create my second string. I'm opening up a new file, so I'm creating a new file actually, and I'm writing that new string to it. Now, like I said, that encryption is very weak. We can strengthen it by changing the numbers. We just have to do so in a way that we can change them back. So for example, the easiest way I can imagine is, what if I was to add the number 3 to that? By adding a 3 to each of these, and let me just close all of this. I've now converted that capital G into a 74 instead of a 71. So now when I run this decryption, my decrypted text, make sure that runs here. Let me just run that one more time here. Yeah, I'm going to not print the list this time. So now when I run my decryption program, you can see everything is all scrambled. So this is much harder to read. Well, it's impossible to read. So this would be my encrypted file. So if this is the encryption I used, I would then take my ciphertext and I would save that as myname.txt and hand it in. So I'd save that as tie.txt, and that would be my entry into the contest. And if somebody just ran this decryption program on it, they would end up getting that. Okay, so how could we break this? How could we get the original song back? Now, I killed that first file, so let me run this again. I renamed it, so let me run this. Okay, so now I've got my ciphertext, and these are the numbers that come out wrong because we added 3 to each of them. So when we go to decrypt this, so when I run my decrypt file, I'm going to undo that by subtracting 3. So remember, before doing this, it would decrypt it as all of this nonsense. However, now that I'm subtracting the 3 that I added, I should get back the original text. There we go. So this one has been hacked. Now, here's a hint for doing this. The most common letter in the English language is E. And the ASCII value for an E is a 101. Also, the most common thing when you write is an empty space. And the number that goes with an empty space is a 32. So all of these spaces should be turned into the number 32, and all of those E's should be turned into the number 101. So when I look through the ciphertext, if I see a lot of 35s, so there's 35s here, each of those 35s represent the spaces that were there. So something has been done to turn my 32s into 35s. And the 101s have all been turned into 104s. You're going to see a lot of 104s scattered around here. Those are all of your E's. So the same thing that turns 101s into 104s turns 32s into 35s. That means this was encrypted by adding 3. So that's one way of figuring out that to decrypt it, you have to subtract 3. So it's entirely up to you however you want to scramble the numbers to encrypt your file. But remember, you have to be able to write a program that can then undo it. Best of luck.